The purpose of this video is to demonstrate OpenShift application's backup restore with DP4CW. We will first do a guided tour of the application to backup, which is an e-commerce application. We will then show how a restore from a backup taken by DP4CW can be used to recover from a data lost. Without going into much technical details, we can say that the application used in this backup demonstration is an e-commerce application based on WordPress and MariaDB containers. The main purpose of the application is to sell curated selection of clothing and accessories. Normal users can access the application using the selected URL. The application offers a shop menu from where clients can browse the list of offered product and order them. Additional menus like blogs, FAQ, contact, etc. are provided. Users with administrator privileges can manage products, users, add menus, etc. Let's say a few words about the details of the implementation of this application and its environment. The application is built under a project called Ecom. By the way, in OpenShift, projects are organizational entities. A best practice is to create applications under different projects. As mentioned previously, this is WordPress application running on OpenShift container platform. From the output of the OC-get-all command, we see that the application is made of two pods. Myriad deployment with this big number for the persistence tier and WordPress deployment with this big number for the business logic tier. If you are not familiar with pod term, then you can see a pod as a wrapper of a container. Here we see that we have only one pod for the WordPress tier and one pod for the database tier. In fact, I can ask OpenShift to create, for example, 3 different instances of the same pod. And if I have, let's say, 3 worker nodes in my OpenShift cluster, then I can have a separate pod running on each node. These pods do exactly the same thing, thus achieving high availability. If one node fails, then no problem, I have 2 other running pods, and my application keeps working. If all the nodes are running, then it's better, because OpenShift will balance the load between these nodes. Deployment. This is the item that groups the instances of the same pod. And it is the resource to use if we need to scale pod numbers and create additional replicas. Route. This is the resource used to expose the services, aka pod, to the outside. This is done by creating a URL that can be used from the outside. Another resource used in this application is PV and PVseed. A PV is a piece of storage in the cluster that has been provisioned by an administrator. Associated to PV is PVC. A PVC is just a request for storage by a user. When a PVC is created, OpenShift automatically finds a matching PV based on the requested storage size and access modes and binds them together. A pod can use the PVC by specifying it in its volume configuration. The pod then mounts the PVC as a volume, allowing it to read from and write to the persistent storage. From the OC-get-PVCs command, we can see that MariaDB pod has claimed a PVC of 30 GB called MariaDB claim, which has been bound to the PV of name PVC with this big number. In the same way, WordPress pod has claimed a PVC of 10 GB called WordPress PV claim, which was bound to the PV called PVC with this big number. We should mention that a backup of this application should first back up these persistence volumes in the first place. In order to back up our application using DP4CW, we need to go through some steps using DP4CW GUI. The first step is to configure the integration between OpenShift and DP4CW. This is done in the Virtual Environments/Virtualization Providers menu. By clicking on the Create button, we get the possibility to enter the details of our OpenShift configuration like OpenShift URL, user credential, and other needed details. The result is a new provider configuration line is created. Next step is to execute the inventory synchronization. In this step, DP4CW use the OpenShift details provided in the previous step to connect to OpenShift and collect all the deployment that could be included in a backup job. To do so, hover over the newly created line and select Inventory Synchronization. This creates an inventory synchronization task materialized by the small gray icon in the status bar. The icon color will switch to blue color and then to red if the task fails, or to green if the task succeeds, as in this case. By clicking on the green arrow in the bottom right side, we can get some details on the task execution and the completion percentage, which is 100% in this case. Once the inventory task completed, we can check what deployments have been inventoried by DP4CW and if our MariaDB and WordPress deployments have been discovered. This can be done clicking on the Virtual Environment/Instances menu. To limit the result to OpenShift items, it's a good practice to filter with RedHat OpenShift filter. MariaDB deployment has actually been inventoried by DP4CW as it appears in this list. By clicking on the MariaDB deployment link, we can get more details on what has been discovered by DP4CW. We can see in particular that DP4CW has discovered the PV associated to this deployment, which is of size 30 GB. In the same way, we can use the Virtual Environments/Instances to check if DP4CW has inventoried the WordPress deployment. This time, I will filter with the WordPress text filtering possibility of DP4CW instead of browsing that huge list as I did previously. Here again, by clicking on the WordPress deployment link, we can get more details on what has been discovered by DP4CW. We can see in particular that the PV associated to this deployment, which is of size 10 GB, has been discovered. Next step is to create a backup job or backup policy that includes the two deployments, MariaDB and WordPress deployment. Backup jobs are created by the Virtual Providers/Backup Policies menu. Clicking on the Create button opens a new window where we can configure the backup job. We can in particular include the two deployments, MariaDB and WordPress deployments, in our backup job along with the backup destination. We are now ready to launch the backup of our application either manually or in a scheduled way. We will launch it manually in this case by opening the newly created backup job and clicking in the small backup icon, then the backup button. Here again, a new task has been created for our backup job, which is materialized with the small gray icon in the bottom of the windows. This gray color means that the job is in a waiting state. The status of the job is now running as the small icon color switched to blue. I can also do some basic monitoring by clicking in the small green arrow in the bottom right of the windows. In the newly opened monitoring windows, I can see that my jobs are running, and I can see the progression percentage. Please don't get confused with the first line, which was created for the previous inventory synchronization task that has already been executed and completed. For deep monitoring, we can use the Unix tail #f command to monitor DP4CW internal logs directly. This is particularly interesting in case of troubleshooting. Back to our DP4CW GUI, we can see that our job status are green. The monitoring window confirms this, as the job's progression show 100% completion. In order to test the restore operation, we need to simulate a data lost. For that, we will use the WordPress admin UI and delete two products. A successful restore operation should restore them. In this example, we will delete the Marina Basic Top and Marina Strap Top items. We can see that now we have only 10 products instead of 12 products before. In order to restore our application from the previous backup and allow the comparison between the original version and the restored one, we have created a new project for the restored version called ecom-r. The ocgetAll command shows that this project is currently empty. In order to restore our application from the previous backup, we can use the Virtual Environments/Instances menu to restore MariaDB deployment first. To do that, we will use the text filtering possibility of dp4cwGUI to rapidly list MariaDB deployment and select it. Hover over this line and click on Restore to Hypervisor Manager menu. This opens a new window where we can fill in the restore options. We will choose to restore to the same hypervisor, which means to the same OpenShift. We will also choose to restore to another project, ecom-r. We will also give the restored deployment a different name, MariaDB deployment rstr. Here also we see that dp4cw has created a task for this restore operation materialized with a small gray icon in the bottom of the GUI. We will go ahead and monitor this restore directly using the tail-f command. We can see that the restore completed successfully. Here we will restore the WordPress deployment. We will go to the same steps as with MariaDB deployment restore to restore to the same hypervisor into the project ecom-r. We will also choose a different name of the restored deployment, WordPress deployment rstr. We can see that the restore has completed successfully. Please notice that for practical purpose, we have accelerated the video, and this doesn't reflect the real restore time. Before checking if we can access our application using the restore deployments and if the deleted products have been restored, we will first check if the target project, ecom-r, lists the same items as the original one. We will use the same ocgetAll command in the new project. From the output of the command, we can see that both pods and their corresponding deployments are present under ecom-r. The only missing item is the route, and that's expected. In order to ensure that we have access to the application from the restored items and not from the original one, we will delete the route defined in the original project using ocdeleteRoute command. We then create a new route making reference to the restored project using ocexposeService command. We will now access our restored application using the newly created or URL. For that, we open a Chrome browser and enter the URL. My restored application seems to be available. In order to check if the deleted products have been restored, we need to connect to WordPress with an admin account as shown here. Browsing the list of products show that my deleted products have been restored and I am again having 12 products.